Have you ever wondered if traffic jams only occur on Earth, or could they also happen in the vast expanse of outer space? Believe it or not, the cosmos isn't as serene and empty as you might think. Just like on our roads, there's a burgeoning issue of traffic up there. We're not talking about alien spacecrafts lining up for an interstellar drive-through, but our own human-made satellites and spacecraft. As we've ventured further and further into the final frontier, we've left a trail of technology in our wake. There are currently more than 2,000 active satellites orbiting our planet, and that's not even counting the thousands of defunct satellites, spent rocket stages, and other pieces of space debris. This celestial clutter is whirling around our planet at speeds of up to 17,500 miles per hour. At those speeds, even a tiny piece of debris can do significant damage. Now you might be thinking, space is big, surely there's room for everyone. Well, that's where things get tricky. The majority of these satellites and pieces of debris are in what's called low Earth orbit, a relatively small band of space around our planet. This is where the International Space Station resides, and it's also the most desirable spot for communication and weather satellites. As you can imagine, it's getting a bit crowded up there, but why should we care? Well, besides the obvious risk of expensive satellites smashing into each other, there's a larger issue at stake. The more debris we have in orbit, the greater the risk of what's known as the Kessler syndrome, a theoretical scenario where the density of objects in low Earth orbit is high enough that collisions could cause a cascade, each crash generating space debris that increases the likelihood of further collisions. This isn't just a problem for satellite operators, it's a problem for all of us. The satellites we have up there are providing us with everything from GPS navigation to weather forecasts, from telecommunications to scientific research. Just like terrestrial traffic, space traffic poses a significant challenge that needs immediate attention. When we think of traffic, we usually imagine cars, buses, and trucks. But what constitutes vehicles in space traffic? Well, space traffic is a bit different from our terrestrial commutes. The vehicles in this case are satellites, spacecraft, and a surprising amount of seemingly insignificant objects known as space debris. When we talk about space debris, we're referring to the countless bits and pieces that are left behind after human space activity. These can range from defunct satellites and spent rocket stages to even tiny flecks of paint. Yes, you heard that right. Even a fleck of paint can become a significant problem when it's hurtling around the Earth at speeds exceeding 17,000 miles per hour. At such velocities, even the smallest objects can cause substantial damage. Imagine a tiny piece of metal, smaller than a marble, colliding with a functioning satellite. The result? Catastrophic damage that can render the satellite useless. But it's not just our technology that's at risk. Space debris poses a real threat to both manned and unmanned space missions. In fact, the International Space Station has to regularly adjust its orbit to avoid collisions with space debris. Astronauts have even had close calls with tiny fragments that have penetrated their suits during spacewalks. Space debris is a growing problem. Every time we launch a satellite, leave a rocket stage in orbit, or even lose a tool during a spacewalk, we're adding to the traffic jam that's building up around our planet. It's estimated that there are millions of pieces of debris larger than a millimeter orbiting the Earth right now, and each one of these has the potential to cause serious damage. Yet despite the risks, our reliance on space-based technology is only increasing. We depend on satellites for everything from weather forecasting and GPS navigation to telecommunications and scientific research. Each new launch, while advancing our capabilities, also adds to the growing problem of space debris. Space, it seems, is not as empty as we once thought. Just as we have traffic rules and signals on Earth, we need a system to manage space traffic. Imagine you're driving down a highway, but there are no road signs, no traffic signals, no lane markers. It's chaos, right? Well, that's a bit how space is today. With thousands of satellites and countless pieces of debris, navigating through it is like driving blindfolded on a road packed with cars. That's where space traffic management comes in. Space traffic management, or STM, is the coordination and regulation of objects in space. It's all about ensuring the safe and sustainable use of the space environment. We're not talking about traffic lights or stop signs in space, but rather sophisticated tracking systems that monitor the movements and trajectories of satellites and debris. Organizations around the world, from NASA to the European Space Agency, are dedicated to STM. They use radar, telescopes, and even AI to track over 20,000 objects in space. That's right, 20,000. These objects can be as small as a softball or as large as a school bus, and they're all zipping around at speeds up to 17,500 miles per hour. By predicting the paths of these objects, these organizations can give satellite operators a heads up if there's a risk of collision. This allows the operators to make small adjustments to their satellite's course to avoid a crash. And trust me, in space, you definitely want to avoid crashes. A single collision can create hundreds, if not thousands, of new pieces of debris, which only makes space more crowded and dangerous. Of course, STM is not an exact science. It's a bit like predicting the weather. You can't be 100% certain, but with the right data and algorithms, you can make pretty accurate predictions. And every day, we're getting better at it. So, while space might seem like a wild frontier, there's a lot of work going on behind the scenes to keep it safe and organized. In the vastness of space, a little management goes a long way. In the battle against space traffic, technology is our greatest ally. It's our eyes and ears in the vast, dark void of space, keeping watch over the swirling chaos of debris. Imagine, if you will, a gigantic cosmic puzzle where the pieces are always moving, shifting, and changing. The challenge is to predict where each piece will be at any given time to avoid catastrophic collisions. This is where advanced technologies such as artificial intelligence and machine learning come into play. These smart technologies, fed with countless data, can predict the paths of space debris with astonishing precision. Consider artificial intelligence, or AI, as the brain of our operation. It analyzes data from various sources, including radar and telescopes, to keep track of the tens of thousands of known debris pieces. It's then capable of making split-second decisions based on this data, alerting us to potential collisions before they happen. Then there's machine learning, the process by which our AI becomes smarter and more efficient. The more data it processes, the better it becomes at predicting the paths of debris. It learns from each prediction, refining its algorithms and enhancing its accuracy. It's a continuous cycle of learning and improvement that allows us to stay one step ahead of the space traffic. But let's not forget about the role of hardware. Sophisticated equipment like ground-based radars and space-based sensors provide the raw data our AI needs to function. These technologies work together in harmony, each playing a crucial role in the fight against space debris. Yet, it's important to remember that technology is not a silver bullet. While it allows us to track and predict debris paths, it can't solve the problem on its own. We must also address the root causes of space debris, such as the proliferation of satellites and the lack of effective regulations. But technology alone is not enough. We need international cooperation. Together, we can ensure the safety and sustainability of space for generations to come. As we venture further into the cosmos, the problem of space traffic will only grow. So, what does the future hold? The future of space traffic management is a compelling subject. With more nations and private companies launching satellites and planning missions, the skies above us are becoming increasingly crowded. The need for robust and effective space traffic management solutions has never been more critical. One promising approach is the removal of space debris. The concept might seem like something straight out of a science fiction novel, but it's rapidly becoming a reality. Various techniques are being developed, such as using nets, harpoons, or even lasers to capture and remove defunct satellites and other debris. There's also the idea of space sweepers, dedicated spacecrafts that could patrol our orbits, collecting and disposing of space junk. This isn't just about keeping space clean, it's about preventing potentially disastrous collisions. But cleaning up our space environment is only part of the solution. We also need to establish space traffic rules to regulate the launch and movement of satellites. This could involve designated lanes for satellites in certain orbits, or perhaps even no-fly zones around particularly congested areas. These rules would have to be universally accepted and adhered to, making space a safer and more organized place. This leads us to another crucial aspect of our future in space: global cooperation. Space is a shared resource, and managing it effectively will require international collaboration. Countries, space agencies, and private companies will need to work together, sharing data and adhering to agreed-upon rules and regulations. This isn't just about avoiding collisions. It's about ensuring the sustainable and peaceful use of space for generations to come. The future of space traffic management is an exciting frontier, full of challenges and opportunities. It's a field that will require innovation, collaboration, and a solid commitment to preserving our space environment. The future of space exploration depends on how we manage the traffic in our skies today